You've got some
Okay.
guys up there that you'll still to fill in, but you should be good with the ones you have filled in.
Yeah, I just saved those ones. Yeah, cool. Okay, I could be able to figure those other questions out. Okay.
Okay, you have a great day.
I had one more. Is there any way that you could go over 7?
Sure. Right, 7s is basically the same question. The information might be given to you in the form of a table, but it's still going to be the same guy. I'm going to write some numbers down so we can use them. Young adults attending college. 96 out of 260 of them said something. Yeah, they got drunk. That's young people. Those who do not attend college, 42 out of 150 of them said they got drunk. Okay, so let's use SALT because we are going to do the null, we're going to do the test statistic and p-value guy. So it's 2 proportions. And the first one is 96 out of 260. That's the young adults I'm using. Out of 260. No, 260. Oh, you'll get it. There you go. And the second one is 42 out of 150. Better rub out the 2.
Why is it doing that?
Okay, now the null hypothesis is always 0. And what we're trying to show is that the first group is bigger than the second, right? That college students drink more than non-college students. So click on that and pick the greater than choice. And there's your p-value and your statistic there. So I think they want the test statistic first, so that's a 1.84 guy. And to 2 decimal places. Now they're asking you here, oh, I sneaky little darlings. The question didn't say, did the first one's bigger than the second? The question, if I'd read it, had said that they are different from each other. So let's hit, you can go back to the previous SALT and just change it. That's the quickest. So we're going to change it to just not equal to, right? And that's going to change your test statistic and your p-value. There's your new test statistic.
Oh, it's the same.
Is it? Oh, well then that's fine. Your p-value, however, will have changed a little bit. And the p-value that you're looking at was 0.06 and some stuff, right? That was the p-value, right? So let's look at what that what our choices are now in the question. Let's see what we're being asked to do. Can you accept or reject the null hypothesis if your p-value is 0.06, but your significance level is 0.05? What is your test? What do you do to decide which of those 4 to choose?
If it's higher than the given answer, you can still reject. So I guess that's the question I have. If it's above,
no, it's not above. No, no. So your test should always be every story, no matter what that story is. You will reject the null hypothesis. That's the way we phrase these questions, or not, depending on, is your p-value less than alpha? Is your 0.0655 then less than alpha 0.05? So is 0.06 less than 0.05?
Wouldn't that be more? Or am I going
more.
Crazy?
And because it's more, you fail to reject the null hypothesis.
Okay. So if I had 0.042,
then you would reject the null hypothesis. You would reject it.
Why would you reject it if it was
let me show you how this works.
So you reject it either way?
No, I think you're picking up things that I didn't say or misinterpreting what I said. So, can
okay.
right, can you give me back control? And we'll do it that way. Right. What I'm saying is very visual. And I think if you see it, it might make more sense to you what I'm getting at. Because I'm just quoting digits here to you in space. And unless your brain's focusing on what that looks like, you're not going to pick up the idea. So let's pretend we calculated a p-value. It doesn't need to be that story, it can be any story. And the p-value happens to be that number. There are two choices. You're either going to be able to say reject the null hypothesis, that's H naught, or you're going to say fail to reject. These are the only two answers you ever get to a hypothesis test. So you'll never mention anything in terms of rejecting the alternate hypothesis or failing to reject the alternate hypothesis. It's one of these two guys. Now, when you say reject the null hypothesis, when you say that, you are also saying that the alternate is true. So although we never say it in that way, we say it, oh, we can reject the null hypothesis. That means that the alternate is true. So what does that tell me? Let's suppose that the null hypothesis is that P was 0.7 and that the alternate hypothesis is, can we prove it was bigger than 0.7? And we did all the stuff and we got this p-value. All you need to do then is compare it against a significance level. Let's suppose the significance level called alpha was that one. You do this test in every question. Is our p-value less than alpha? And that doesn't care if the alternate is a bigger than, a less than, or not equal to. That is not what's going on here. It's always this test, no matter what the story would be. Is our p-value less than alpha? In this question, 0.031 is less than 0.05. And if you say yes to this question, then this is the one you pick. If you do a hypothesis test, and let's say for argument's sake that the p-value ends up being 0.083 and that the significance level was 0.05. If that had been the guy that you got, your test is still going to be, is the p-value less than significance level? And the answer in this case, is that true? And you're going to say no. And when the answer is no, this is your conclusion. When the answer is yes, this is your conclusion. And the p-value comes out of from SALT, and it doesn't matter if the hypothesis was, can we prove something's bigger than a number? Can we prove some proportion is less than a number? Can we propose that it's not equal to it? When you do a null hypothesis and it's two stories, two proportions, that's what the null looks like. And the alternate, one of its possibilities is that. But apart from that difference, you're still going to get a p-value and you're still going to do the exact same test. And if the answer to the test is yes, you're going to pick this, reject H naught. And if the answer to the test is nope, it's not true, you're going to pick fails to reject. So it doesn't matter if it's a 1 proportion test or if it's a 2 proportion test. Later on, you'll find out it doesn't matter if it's a single mean hypothesis test or the difference between 2 means hypothesis test. This test is the same test. And if the answer, your p-value is less than significance, you're going to say yes, and yes means reject H0. And if your answer is that it is no, it's not less than it, then you will pick fail to reject. And these are the final results to every hypothesis test. Does that kind of clarify
that
what?
makes a lot more sense.
Right. So every time you do one of these, your job is just find the p-value. Once you know that, you've got 2 choices. You either say this one or that one, and you decide on this.
Okay.
What does my test tell me? Yes or no? If it's yes, do this. If it's no, it's not true, do that.